This is section 4.5, and this is about L'Hopital's rule. John Bernoulli discovered a rule using derivatives to calculate limits of fractions whose numerators and denominators both approach zero or positive infinity. The rule is known today as L'Hopital's rule. He was named after Guillaume de L'Hopital. He was a French nobleman who wrote the first differential calculus text where the rule first appeared in print. Limits involving transcendental functions often require some use of the rule for their calculation. And so what it says is that if you have a limit as x approaches 0 and you can't direct substitute, you can't plug in zero for x, you can't factor, that perhaps you can use L'Hopital's rule, which says you take the limit on the left and the limit on the right of top and bottom and see if it fixes the problem. So, example, the limit as x approaches 0 of 3x minus sine x over x. Obviously, we cannot plug in x for 0. So, take the derivative of the top. That becomes 3 minus cosine x. Derivative of the bottom, derivative of x is 1. Well, now we don't have a problem. We can plug in 0 here. Cosine of 0 is 1. So, we have 3 minus 1 over 1. So that limit is 2. If it doesn't work the first time, you can continue to try to see if it works. And unless you get in a loop, like with an e to the x, something that's never going to change, you usually will get to something that will work. So on this one, you can't substitute. So we take the limit. We get 1 minus cosine x over 3x squared. Still can't plug in 0. Do it again. The limit of 1 is 0, and then this becomes negative sine x, so that's a positive sine x over 6x. Still can't. Do it one more time, and we have cosine x over 6. We now can plug in 0. Cosine of 0 is 1, and we have the 6 on the bottom. So that's the idea. So that's not very many notes, and we're going to go look at the problems. I think we have 4 problems to do just to get a taste of this, so let's go look at that. Number 1 says use L'Hopital's rule to find the limit, and we have 3x minus 15 over 5x squared minus 125 as x approaches 5. So if we were to plug in 5 here, that would be 125 minus 125, so that doesn't work. So on the top, the derivative is 3. On the bottom, the derivative is 10x. So now if we have the limit as x approaches 5 of 3 over 10x, you can plug in the 5 and you get 3 over 50. Number 2, limit as x approaches infinity of 3x cubed minus 6x over 7x cubed plus 7. So I'm not even sure that I would use the rule here, but I went ahead and did it, just put it up here for you. So if you took the derivative of the top and the derivative of the bottom, you end up with 18x over 42x, and do it one more time, you've got 18 over 42, and the limit of a number is going to be the number as you go to infinity, and so that's 3/7. But if we remember back from algebra, when you have a rational function and the denominator the denominator degree and the numerator degree are the same, then the horizontal asymptote as you approach infinity is the leading coefficient over the leading coefficient. So as you go to infinity, this is 3 over 7, and that's would probably be my thinking, and I probably wouldn't try to use the rule, but it does work. So I showed you both ways there, and we end up with 3/7. Let's look at number 3. We've got, as you approach 0, 3x squared over cosine x minus 1. So if we take the derivative of the top and bottom, we have 6x over minus sine x. So the sine of 0 is 0. So that doesn't work. We have to repeat. So then you take the derivative of this is 6. Derivative of this is negative cosine x. We can now put in 0. And we have negative 6 over 1, and that is negative 6. The last one is number 4, and you have, as theta approaches pi over 2, let's see, if you, the sine of pi over 2 is, well, we're worried about the bottoms. Let's look here. So if you put pi over 2 here, for theta, 2 times pi over 2 is pi, and the cosine of pi is negative 1, but the sine of pi over 2 is 0. Let's see what we got here. Let me check. Okay, so I have added just the original just to show you. So if you have 1 minus sine of pi over 2 over 3 plus 3 cosine of 2 times pi over 2. So this becomes 1 minus 0, which is 1, because sine of pi over 2 is 1. And then down here, this is cosine of 180 is negative 1, so you have 3 plus a negative 3, that's 0. So we cannot plug in. So when we take the derivative, we end up with negative cosine theta, negative 6 sine 2 theta. Again, you're going to get 0, 0 if you plug in pi over 2. Take it one more time, and we have sine theta over negative 12 cosine 2 theta, because it's cosine theta, cosine 2 theta, negative 6 cosine 2 theta times 2, and that's where that negative 12 comes in. So then sine of pi over 2 is 1, and cosine of 180 is negative 1. Negative 1 times negative 12 is 12. So it's 1 over 12. And we took out number 5. So you really just have 4. You're not going to use this very often right now, but it is a chance to practice. So let's